Hello everyone. So today we will solve the third numerical based on the 2D transformation. Okay. So before that we should read a question carefully. So question is like this. A polygon having coordinates 2, 2, 4, 5, 6, 8, 11, 4 is rotated about a point 9, 9 by 30 degree in clockwise direction and scaled by 2 units in the x direction, 4 units in y direction. Find the new coordinates of the polygon. So in the given question, so the coordinates are given of 4 vertices, right? It is rotated about a point. Okay, remember this is not rotated about the origin, it is rotated about the point 9, 9. So this is very important information given in this. So it is rotated about point 9, 9 by 30 degree. So it is rotation is about 30 degree in clockwise direction. Okay, so clockwise direction is given, means we should consider the angle of this or this angle should be a negative, because clockwise we will consider it as a negative, right? Then scale by 2 units in the x direction, means sx value is given, it is equal to 2. Same way sy value is given, it is equal to 4. Okay. I will just give you one pro tip for you. There is some confusion, like if it is only given that it is scaled by 2 units in the x direction, find the new coordinates of the polygon. So what will be the value of sy? As it is not mentioned, don't take it equal to 0, right? It should be equal to 1. Always consider, if it is not given, the scaling factor should be equal to 1, not equal to 0. Remember this point, this is very important. Now we'll try to solve this numerical. We'll go to the next slide. See, we'll try to plot that particular point there on the graph. So the P point is somewhere here, right? I will consider this point is equal to 9, 9. So this is the actual location of point P against which we need to do the rotation and scaling operation. Okay. So remember, all the formulas that we have, they are all implemented considering the origin, right? So they are, if you rotate any object, it will be rotated against the origin, right? So that's why it is required to transfer this P point to the origin, right? So the first step is transferring this point P to the origin. Okay, so for that we require a translation operation. Get it? Then we'll do the rotation operation as per the given sequence. Then we do the scaling operation, and then we translate it back to the original location, means from this point to this point. Get it? Again, translation operation is required for that. So this is the procedure for that. Okay, so first matrix will be, just a minute. So the first operation we required is a translation. Okay, so it will be translated in by using this matrix 1 0 tx 0 1 ty 0 0 1. Okay, now in order to translate it to the origin, okay, I will just make it simple for you. Can you tell me what are the coordinates of the origin? They are 0 0, right? So if you subtract -9 and -9 from the coordinates of P, then it will become 0 0. So same way here we should put Tx is equal to -9 and Ty is equal to -9. Getting? To translate it to the origin. After this, the second matrix is required. As per the given order, we need to do the rotation operation. Okay? So the rotation comes second. Here also, one thing to remember, that theta is equal to -30 degree, as it is clockwise rotation. And if you remember from the last lecture, cos of minus theta is equal to cos theta, sin of minus theta is equal to minus sin theta. You can implement that. Okay, then we will do the scaling operation. So for that we'll use this matrix here. So the third matrix is a scaling matrix. I think this is the fourth one. I will write it here. Okay, so third one is scaling matrix. Simply that scaling factor is given directly, we can use that. The Sx value for this is 2 and Sy value is equal to 4. Okay, after doing rotation and scaling, we will transfer this point back to its location. So the next matrix will be similar to this matrix. Okay, I will just copy it and paste it here. So fourth matrix will be same like the translation matrix, but now the coordinates of point P are 0 0. We need to make them 9 9. So we need to add plus 9 in the x and plus 9 in the y, right? So tx is equal to 9 and ty is equal to 9. So in this way we get t1, t2, t3 and t4, right? Get it? So we require 4 matrix to find out transformation matrix. Okay. Now about the multiplication, we should multiply in the reverse sequence, right? So T4 is multiplied to T3, T3 is multiplied to T2, and T2 is multiplied to T1. Okay. So that we'll see in the next slide. Just you can note down all those things. You can pause the video and note it down. Okay. Just remember those values. We'll go to next slide. Now see here. So in order to get a transformation matrix, as we have discussed in the previous slide, T4 should be multiplied to T3, T3 should be multiplied to T2, T2 should be multiplied to T1. Get it? So you can put all the values here. Okay, I will write here. So here Tx value is not minus 9, it is plus 9. Tx is equal to Ty, both are same, both are equal. So it is equal to 9. The Sx value here is equal to 2 and Sy value here is equal to 4. Same way cos theta and sin theta. So theta value is given, it is equal to minus 30 degree and Tx is equal to Ty is equal to minus 9 here. Getting? So now put the values in this equation. So here comes 9 9. Okay, I will try to write it if possible. So here is 9, here is 9, here is 2, here is 4, then theta is equal to minus 30. It makes complicated, so you can understand. Here is minus 9, here is minus 9 also. Getting? So just multiply this matrix into this, or you can enter first 3 matrix in the calculator. You multiply A into B into C, find out the answer, right? Your answer will be like this. This is the answer of multiplication of 3 matrix. Okay, again you enter this matrix in your calculator, you enter this matrix and multiply the answer of these 3 matrix. Okay, in a calculator it can store the answer. Calculator is not there, otherwise I will exactly show you that function, but it is like this mat ans. I'm not exactly sure, but mat ans function stores the multiplication data of previous matrix multiplication. Okay, so you can multiply mat ans into the next entered matrix so that you will get the final answer. Okay, I will erase this thing. So the final answer of this thing is equal to, after doing the calculation you can try it on your own. Okay, this is not the thing. So transformation matrix is equal to 1.732. Just a minute. So the transformation matrix is equal to 1.732, 1 minus 15.58, then minus 2, 3.46, minus 4.176, 001. This is the final answer that we have got. We'll multiply this thing with the vertices of that polygon. Okay, you can do it in a single stage also. So that vertices of that polygons are, so they are 2, 2, 4, 5. Okay, just remember those things. 2, 2, 4, 5. Note down in this sequence only, x, y, 2, 2, 4, 5. Then 6, 8, 11, 4. 6, 8, 11, 4. The last row should be 1, 1. Okay. If you do this multiplication, you will get the final coordinates of this point. Multiply this matrix. The last row should be 1, 1, 1, 1. By default, it will come 1, 1, 1, 1. Try to find out this thing, and it should be equal to minus 10.12, minus 10.12, minus 3.66, 2.8, 7.47, then minus 2.48, 1.24, 25 we can say, 5.14, 11.54, and minus 12.37. In this way, you can easily find out the coordinates of new points by just multiplying. Okay, so for that, you can note down this answer. I will delete this. For that, you should have thorough understanding of this, how to write a matrix and how to multiply them, and then only you can able to find out the final answer. Getting? I hope you understand and enjoy this lecture. I will give you one sample question which you can try on your own and try to answer the question. Okay, you can comment the answer of this question in the comment box. Okay, thank you very much.